Good evening, everybody. Thank you for taking the time out to attend this evening event. As you'll no doubt be aware, this webinar is on the topic of the Thames Tideway project. We have Kevin Mullins and Stuart Stanford, who have been kind enough to talk us through this project. Kevin Mullins is an Associate Director for Infrastructure for London and South East. Kevin's a chartered engineer with extensive experience of leading multidiscipline engineering design teams on Crossrail, the 2012 Olympic Park, and the Thames Tideway and Hinkley Point C. Stuart Stanford, also Atkins, is a chief engineer for hydraulics and surge, and is a chartered engineer and has extensive experience in the water industry. So they will be guiding you through this event this evening. If we can just flick to the next slide, please, Kevin. And I just wanted to run through some just general housekeeping, and then I'll pass you over. The webinar is being recorded. We put our recordings up on the Saron website only. They won't go on they will go on YouTube if the author has given permission. There are other events, previous events that have been run by our other committees that you can also find online as well, should you wish to review any of those for CPD or for your own interest. If you have any experienced any technical issues or need assistance in any way, then you can let us know by just putting something in the chat or raising your hand. The speakers won't be able to see that, but Barbara will be working in the background to make sure she can help you out where we need to. And incidentally, Barbara will be dropping in links into the chat as well for any of the material that's been discussed during the event. We will have some questions at the end of the presentation. If you would like to make a question, then obviously there's the Q&A facilities or the chat, or you can raise your hand at the end. And for anybody interested in this kind of thing, this is worth 1.25 hours of CPD, and we don't provide a certificate for the event.
If I could just say that if you have any questions or comments, if you could put them in the Q&A, because then those can be fed into the speakers. And also we'll have a record then of the questions that have been asked. So if we run out of time, we'll be able to, we can then address them. Thank you.
Thanks, Barbara. Okay, so without further ado, I'll pass you on to Kevin and Stuart. Thank you very much.
Excellent. Thank you very much, Rob. As you gathered today, we'll be talking about the Thames Tideway Tunnel, otherwise known as Tideway, particularly the west section, which Stuart and I worked on for a number of years. We'll be going through a safety moment, some of the overview of the project, as well as the specific challenges of the locations and the operations of the sites as we go through. One of my pet sites is Putney Embankment Foreshore, and so I'll be using that as some of the examples to show how the sites progress, some of the challenges we have, and some of the unique solutions that we've had to develop going through, including the hydraulic modelling and validation. Using the same examples, we'll then talk about how we've used the digital twins and BIM technologies in order to coordinate and collaborate through the systems. A little reminder, just in order to keep broadband width down and make sure everyone has the best experience possible, if we can stay on mute and videos off until the end, we'll be picking up all of the questions. So we have safety, integrity and ethics moments when we start meetings. So I thought I'd choose one that is very relevant to the Tideway scheme. and that is epic behavioural safety. Tideway embarked on an aspiration to really make a difference in health and safety on construction projects. And the behaviours of the people on site are the most likely things. Once you have taken into account the normal controls and mitigations, the next step is how do we change people's behaviours to make a safer, more inclusive site. And so Tideway put everyone, all of the designers and all of the site staff through this epic safety. It was a full day, not just talks and scenarios, but it was also role playing in order to get everyone involved and practice how to engage meaningfully. And part of the epic training was to instill a confidence in everyone that they can speak up and question decisions and authority. Traditionally, site is quite hierarchical, and having a framework to be able to ask meaningful questions and have the ladder of challenge to be able to ask and understand if you don't if you see something that's on first glance could be misinterpreted or not understood, and hence arise to a situation or a reaction that isn't conducive to excellent safety. And very much the big change comes out from the action and reaction cycle. Quite often there's a reaction to something that happens on site, and if we can break that link, then you can interpose much more logic orientated reactions and have a safer and more collaborative site to improve safety. So the project itself is split up into 3 sections: west, central and east. Each of them have their own challenges, not least of which is the geology. The main tunnel itself, stretching from Hammersmith to Abbey Mills, is 25 kilometres. The diameter is between 6.5 to 7.2. I believe the standard measurement for these is double-decker buses, so you can fit 4 double-decker buses within the cross-section of the tunnel. And it falls from the west all the way to Abbey Mills pumping station in the east, where it connects to the Lee Tunnel, which has already been constructed and conveys sewage flows out towards the Beckton sewage treatment works. When completed, the tunnel itself will be able to hold 1.6 million cubic metres of water or sewage. Again, the standard unit of measurement for this is Olympic swimming pools. So it'll be the equivalent of 600 Olympic swimming pools. Stuart and I were involved in the west section as part of the Atkins Arab joint venture. I'm going to just go through a very high-level background. At the end, I have a link to the Pipeline Industries Guild talk by the Tideway West engineering manager, Colin Murphy, who provides a lot more detail about some of the background information should you wish to investigate that further. So in the west, we were tunneling through clay. The drive site for the west was Carnworth Road, and the tunnel bored towards the west towards Acton storm tanks. In the central section, there were 2 bores. Starting at Kirtling Street, they went towards Carnworth Road and towards Chambers Wharf, either side. And then in the east, they were tunnelling through Chalk, going out towards Abbey Mills pumping station. With the main tunnel, the Frogmore Connection Tunnel and the Greenwich Connection Tunnel, they form the 3 tunnels, part of the Tideway tunnels, plus the Lee tunnel, as I said, was already constructed. So the west section consisted of 7 work sites. There were 2 primary work sites which were on the line of the main tunnel, Carnworth Road and the reception site at Acton Storm Tanks. These online tunnels or shafts were large enough to receive and launch the TBNs. So it was approximately 30 metres in diameter, and driving all the way through, it picked up the smaller connection tunnels from each of the sites in between, and the Frogmore connection tunnel came through into Carnworth Road itself. The main tunnel through the west is 7 kilometres long, with a 1 kilometre extension Frogmore connection tunnel. I started the tender on Tideway in 2013, and upon planning approval in 2014, we were awarded starting works in 2015. At the moment, the west and central sections, the tunnelling has been completed, and the secondary lining is being installed, with the east section well underway as well. It's anticipated that all works, including commissioning, will be finished by 2025. So why did we need this project? The main aim is to improve water quality. London is a conglomeration. Very much it was built up rather than planned. And a lot of the rivers of London were subsequently culverted over, and what were the open sewers became culverted sewers, and then placed into the river through overflows. The Thames Tideway project aimed to reduce the number of CSO discharges. Bazalgette constructed a series of sewers which intercepted the open rivers, but due to the increase in population, some from 2 million to the 30 million plus that it is today, there is approximately 50 to 60 CSO discharges per year, with the impacts on human health, dissolved oxygen, ecological and habitat impacts. So there was an impact to the water quality, and 36 of them were deemed unsatisfactory. As part of cleaning up the Thames, it had a real opportunity to encourage river use. So not just the recreational users, rowers, boatmen, but also to revive the industry around the River Thames. So lightermen and barge operators. And a lot of the constraints that you'll see in a moment have been overcome by reuse of the river. Having the strong aim of river regeneration, clean rivers, healthier population of London, was a real project identity that the staff and operatives around the project can buy into. And that gave a feel-good factor. So even when the demands were on and the deadlines were pushing in, there was a real sense of achievement for having working on such a project with strong environmental goals such as Tideway. So I've mentioned the location challenges. The majority of the sites are all what we'd classify as typical central London sites, highly constrained. The picture at the top of the screen is Putney Embankment Foreshore. So between the bridge and the jetty is the worksite. The interception itself is underneath the bridge, and all the access would have to come off of the foreshore there. It's characterised by heavily traffic flows, particularly at peak hours, a congestion of utilities. As you can see, it's heavily overlooked by influential and highly educated property owners. And as such, they are very able to engage with the DCO and object meaningfully should there be any issues with the construction. And not just here, but there are many high-profile locations. So Putney is the location of the university boat race where they start, and there was a condition that the site would be required to be used by the boat race to start. As it happens, due to the COVID shutdown, the boat race hasn't taken place, but provisions were in there in order to protect the markers for the boat race and to be able to shut down site operations in order to have those. And similar provisions were in place for the Chelsea Flower Show and other events, key events down the river. So along the River Thames, there are iconic buildings, places like the Houses of Parliament, Tower Bridge, and there were over 45 tunnels that need to be assessed and managed in terms of settlement and space planning, avoiding, along with 75 bridges and 24 listed buildings. And certainly when we came through, the project came through the middle of town, Chelsea, Blackfriars, Victoria Embankment, all of those sites would have the same characteristics. So what does a site look like? Using Putney as the example, the main sewer is within the embankment or the road itself. And then there's an overflow typically, which allows the sewage to overflow into the Thames. And this is where we would capture it. In this case, we had an end cap, but other places we intercepted the overflow pipe or attached an interception chamber to the side of an existing pumping station, like at Hammersmith. So the interception chamber here, underneath the bridge, allowed the overflows to drop down into the connection culvert, which linked the interception to the main site. On many sites, this was short, but on Putney, we had the existing slipway. So the slipway was required for access, not just by boat users, but also there's a provision for river haulage historically to be able to access the river at this location. That meant there were a number of design challenges around boat loading, boat grounding, scour, environmental reinstatement of the riverbed, which were all required to be managed as part of the design. So those elements influenced the connection culvert, and the sewage overflow would travel down the connection culvert into the isolation chamber where our primary penstocks would be housed. These are hydraulically actuated penstocks to be able to shut the flow off should the certain conditions in the tunnel be required. So either it's closed for maintenance or it's approaching capacity, we have to close it off and then revert the overflow into the river, which is into the page towards us. To the right, we have secondary isolation valves and non-return valve before coming across into the vortex generator. The vortex generator, which Stuart will describe in just a moment, will convey flows down the shaft for conveyance further on into the tunnel. I find my mouse. Okay, Stuart will talk you through the hydraulic principles.
Thanks, Kevin. Right, as Kevin said, we need to drop the flow from fairly high level, like near ground level, into the main tunnel. And we don't just drop it into the main tunnel, we drop it in a shaft, and then there's a little tunnel from the bottom of that shaft into the main tunnel. There are two real parts to these structures. There's the top part, which we call the vortex generator, where the flow comes in through a tapering channel that's also sloped like a ramp, and that gives us a spin to the flow that then drops it down the drop tube to the bottom where we let all the air out safely, and then it's connected into the main tunnel. There was quite a well-developed reference design from Tideway, which we were given, but we then had to develop that into detailed design so that our colleagues in the joint venture, BAM Nuttall, etc., could actually build it. So we were particularly interested in some of the geometry. We had quite onerous specifications on velocities, freeboards, gradients, make sure everything's self-cleansing, which leads you to certain velocities. So we used a whole host of industry standard methods, things like Syria 141 for sedimentation transport, to show that that long section of culvert, that we wouldn't get things dropping out in that it would all make it into the vortex generator. There's some academic papers that tell you how to size these things, which I will move on to in a moment. And as part of the design, the reference design had some physical modeling done at the University of Iowa in the States. But as part of our design, we were required to use CFD, which is computational fluid dynamics. And we also had to do some validation by another physical, well, more than one physical model actually, to validate some design changes that we want to put forward. Okay, and just at the bottom one there, just go back one, Kevin. So the vortex generator itself is quite robustly designed and engineered so that at way above the design flow, we went to 150% of the design flow to show that we were still getting a stable vortex. Okay, next slide. So the ramp and the taper comes from a paper by Ewan Lee, which hydraulics of tangential vortex intakes in urban design. That is the reference paper that the geometry is all based on. We did size these to meet certain client specific requirements, one of which is the 150% stable flow thing. The other things to note here are, as the flow comes down the ramp, we've normally got a hydraulic control and brake point at the lip of that ramp, which it's important that we maintain that, so that gives us a defined depth to flow ratio, so that if you can measure the depth, you can measure the flow, which is important later on. But as the flow comes down that ramp and then hits the circular drop tube, it starts to spin, and you have to make sure that once the flow has gone through its first 360 degrees, that the depth of flow in the tube isn't high enough to affect the upstream depth at the lip, so that at all times you know what depth you should be getting for a given flow rate. And I'll come on to that in some of the other things we did with CFD and physical modeling on how we validated all of that. The other thing is that,
sorry, Stuart, I was also going to say, and that was also important for the measurements for the automation and tracking of the flows, wasn't it?
Yeah, and another important requirement is that you don't want the air core in the vortex drop to be too small. So there's a ratio there of it's got to be greater than 0.25. If you start going smaller than that, you run the risk of the vortex choking, which would be bad news. So there's some fairly robust requirements on that over and above what's in the Ewan Lee paper, which gives the basic empirical equations that were used. The other thing is that another client requirement was that the width of the minimum width of the taper, I think, is 550 mil, so that it can't get blocked by large debris. So there are things over and above what's in the academic paper that as engineers we have to consider. So next slide. So this is some of the validation that we did. We used CFD, and as Kevin has alluded to, it was the design team was a joint venture between Atkins and Arup, and it was a blended design team. So sometimes the CFD was done by Atkins when we use Star CCM Plus, and sometimes it was done by Arup. They used a thing called Open Foam. And as Kevin will come to this later on in the presentation, you didn't really know in the design team who people work for. It was a completely blended team. So there we can see some of the standard sort of images you get from CFD, and also some of the physical model images. We'd also worked out, if you like, using traditional 1D calculation methods, what we thought the levels would be for given flows. And when we had that, we could then compare that with outputs from CFD and from the physical model. And we got very good agreement on that, which gave us the confidence that the design was robust. Okay, next one. So then quite a challenge for us was this thing called the deaeration vent pipe, which in the bottom right hand image you can see there's a little narrow tube with a little bit of blue in it. The CFD coloured the water blue, and that tube was actually outside the main shaft. We had a shaft built at Putney, and the vortex drop sits inside that shaft. The reference design had an external vent pipe as well, which meant it would be quite a difficult connection to make, because we've got to drill down or excavate down approximately, I think it was about 25 meters from ground level to where our little connection tunnel is. That was quite an awkward connection to make, and you'd also have to maintain it. There was all sorts of discussions around how we could protect that, because the main shaft is inside a cofferdam, a permanent cofferdam that had was designed for certain barge impacts and things like that. But even then, we were worried that there was a point of failure with that vent pipe. So we thought we could maybe design that out, which led us on a bit of a journey. The starting point of that journey was look at it in CFD. So we did it in CFD with and without, and that was telling us that we could probably remove it. So then we had to validate that with some physical models, and The images on the right, top right and the top left, sorry, and the bottom two on the left are of a physical model of that installation. They were done by Hydrotech in Leeds, and there was a client specification for the amount of air that's passed forward, and Hydrotech were able to develop a technique to actually measure that amount of air, so we could quantify it, how much air was going forward. The physical model was built so that we could do it with and without the vent pipe, and we were able to show that we were well within the acceptable specification requirements, even with the vent pipe removed. A further sort of clever refinement was there was another site at Barn Elms, which is an almost identical layout, and with a little bit of tweaking to the model, we were able to model that one as well. So we basically got 2 sites done for the price of one, with one model, with a bit of forward thinking on how we would do that. And I think that's me, Kevin, and back over to you.
Excellent. I know it may seem on the face of it a simple design change, but actually it had a lot of implications, positive implications, in reduction of construction risks, maintenance risks, and durability of the scheme. And so Stuart and I are actually quite proud of this one, considering that we went to great lengths to prove the effectiveness of it as well. So coming up, we have got some pictures of the site. So the top 3 are pre-development. We can see an open stretch of beach with 2 overflows underneath the bridge. The overflows under the bridge are constricted working spaces. We would be working intertidally, undermining potentially the listed bridge itself, and a lot of restricted working practices and piling from above. That was very difficult. So the contractor, Ward & Burke, that came on board, had some innovative changes which we helped them implement, and I'll talk through those in just a moment. So on the bottom left of the screen, we can see the sheet piled cofferdam wall, which was filled in, and then the main chambers and shaft was sunk as caissons, which allowed then the connection culvert to be built. The sheet piled elements also formed flood protection, and so they formed permanent works, but in the temporary case they were extended higher to form both edge protection and flood protection, and then they were able to be cut down to their permanent level to be retained for the work. So being quite efficient with as much of the permanent elements as we can do. In the bottom right is an impression of the site as it will be when finished, with timber on either end, stone cladding on the front to replicate the bridge, and a signature vent column which would allow the passive release of air. And the things that tie the site in to the boat race, we extended the University boat race line along the paving to make a feature of it, and also the hand railing will have artistic impressions of oars and other details along the vent pipe in order to tie the place in with the boat race. So talking about the connection culvert, so the purple connection culvert was turned into a connection tunnel. Contractor Ward & Burke proposed a micro tunneling machine in order to drive up, past through the bridge into a reception pit, and we can see a picture at the bottom right there of the mini TBM being extracted from site. what did that do? It removed a lot of the intertidal working, and so hence reduced a lot of the risk of site. But also using a pipeline technique, it was a continually reinforced pipe, and which provided greater stiffness. Some of the problems we were facing as design challenges were differential settlements, with the large interception chambers wanting to settle more, and then the connection culverts wanting to be buoyant, and the differences working between those needed to be tied in and managed in order to prevent any steps and allow the free flow of the water through. So the more rigid connection tunnel, we were able to prove the beaching of vessels above resisted that. Because it was tied in, it resisted flotation, and we're able to manage the forces, the interception chamber, and tie that in and make it work as a whole. The other two are of the ecology. So we disturbed less of the riverbed, kept the habitat, and also the archaeology. The River Thames, the beds are excellent sources of archaeology. There's a whole host of even Bronze Age finds that can be found along the Thames, along with longboats and all the pottery and coins that are found as well. So we managed to preserve those and remove a lot of the risks from the archaeological studies. Now, we didn't do this alone. The design venture was Atkins, a well-established partnership that had worked on Crossrail and other successful projects. And the tips are really an open and honest relationship, setting it up from the beginning to be collaborative and having that willingness to share and collaborate over confrontation really set the scenes for us to be fully integrated. And as Stuart was saying, quite often both Tideway and the contractors couldn't tell who was from which party because we were fully integrated through that team. The contractor itself was a mixture of the three main contractors, BAM Nuttall, Morgan Sindel and Balfour Beatty, and they were also co-located with us in order to develop those joint methodologies and techniques. This was all facilitated by a common data environment we used ProjectWise, and sharing the models to achieve the BIM level 2 compliance. So at the top of the screen, we have the DCO scheme, and at the bottom, we have the Gate 5 construction model, which if we zoomed in, we could see the hand railings, we can see all of the openable covers and the space proofing for the services, utility containment and kiosks. And very much this allowed us to step through both constructability and the operational reviews. So the opmans and the HAZOPs were literally stepped through chamber by chamber. We could see where all the safety features were. You could then discuss around what was observable from each of the platforms, and we were able to prove through the models the CCTV surveys, where we were able to drop a virtual camera through and take images all the way down, and prove a way of maintaining and reviewing the condition and de-risking a lot of the man entry requirements. We have skimmed through a lot of this information. Having worked on it for a number of years, there are many aspects that we could go into in detail. but two excellent sources of information, one of which is the Tideway website itself, where you can look at all of the sites across the scheme, track the tunnelling machines and the progress, and they also put in updates to show how the different sites are progressing. It's very exciting that Putney is receiving all of its cladding at the moment. So they're putting on the granite cladding, and the outfalls will be fitted very shortly. As I mentioned at the beginning of the talk, Colin Murphy, who we worked with closely, undertake a talk for the pipeline industries, and that goes into some of the background about the history and how Bazalgette improved and how we're building upon the good work, and also the historic flows of the sewers. So should you wish to investigate a bit more of the history, those are excellent sources of information. We would invite you now to ask any questions. We do have some images of some other sites that we could go through, but the floor is open.
Excellent, thank you, Kevin. As Kevin mentioned, we've got a Q&A, or you can ask something in the chat function as well, or if you'd like to raise your hand or get in touch any way like that. I think in the meantime, probably a question for me. I don't know. In my role in the Environment Agency, I do a lot of working with joint ventures, and I suppose one of my questions is, what are your kind of main kind of lessons learned, I suppose, in order to try and you know, generate that collaborative working and you know, be more effective that way.
Okay. Selection of a partner that has the same values, and so very much the same approach to excellence in quality. You could have ethical values that align, and I mentioned that we'd both worked together on Crossrail as well, and so we have had projects where we've been working in each other's offices. As it so happened on this one, we co-located with the contractor in their office, and whilst we had teams across the country, and there were a core of people sat together, and they were the drivers behind. So very much making sure there was equality and equal distribution of resources and support. And as part of that, we found we were actually mentoring each other. So there was a stagger in all of the roles. So if we had the project director from one company, the project manager would be from the other. Then the design manager would be from the first company, and then some of the discipline leads would be from the other. So at each stage, we're swapping ideas and having that integration. If you set up a siloed approach, that makes the differences more apparent. So having the co-location and integrated approach and swapping the roles very much help to break down those barriers, and the same ethics, levels of detail all help to collaborate and to success.
I think having that staggered structure is a really interesting feature there. That was good. We've got a couple of questions in. Will the project be delivered within budget?
Well,
or your part of the project, I suppose.
Very interesting. We don't see some of the budget, but as you may be aware, the rising shipping costs and material costs over the last 2 years, exacerbated by quarantine regulations, by evergreen shipping, blocking the Suez Canal. So I believe that steel prices have risen sort of 6-fold. There's a shortage in cement and bricks. And so there will inevitably be a knock-on impact to the construction cost, but I don't think that it is reflective of what we designed.
Yeah, I think you can only control what you can control.
Yeah.
Okay, regarding the specifications in the design of the different schemes, how were the materials chosen and why? Also, were they done by Atkins / Arup / both / all the contractors?
Okay, interesting question. So we, at the outset, both the design partners inputted to typical materials. In particular, we looked at the concrete mixes and the cement replacements we could get in order to drive down the amount of cement. Now, this was a number of years ago. As it turns out, that those measures that we implemented are the same sort of measures you would do to deliberately drive down the carbon costs of concrete. But 5 years ago, that was good design, and very much we didn't have the carbon calculation in mind, but very much the experience that we drew together contributed to that. Also, at sites like Putney, instead of having all granite cladding, we incorporated the wood facade in order to help soften and have more ecological materials. And I know at other sites they had terraces and to bring in that variety of materials as well. Inevitably, the standards, because the majority of the assets aren't available for maintenance, they're buried 50, 60, 70 meters below ground. Durability was a key concept, and there's a two-sided argument about whether you design something for an extended life cycle. So in this case, it was 120 years plus, because you wanted that, Tideway wanted that Basel jet legacy, something that will last and be reused and be appreciated for the longevity of it. It did mean that some of the elements were robust, shall we say, but over the whole life, that could be seen to be a positive.
Yeah, okay. We have another question. Do you have any predictions on any quantifiable changes in water quality attributable to the Tideway project, such as an increase in the number of watercourses achieving good water quality?
I'm sure Tideway have that information. I don't have it available at the moment, but certainly the prediction of removing, I can't remember the figures, it's something like 80% of that overflow that would go into the Thames. We're talking about over the lifetime millions of tons of sewage that would be discharged will now be captured and taken through to the Beckton sewage treatment works. And I mean, yeah, I mean, that in itself is a massive goal and improvement aim. Obviously the proof will be the testing and recording that will go on post 2025 when everything's in place and commissioned. And we, hopefully have that good feeling continue as we see water quality continue to rise.
Absolutely. Okay, how many shafts are being constructed in total, and how is learning shared across sections of work as it progresses?
Okay, so I think I had at the very beginning, there was 24 shafts. Let me just double check that. or 24 work sites, which effectively is 24 shafts. The large ones are the ones that are online. The majority of the run is below the river, and so the actual shafts themselves vary in size. As I said, the drive shafts and reception shafts are circa 30 meters diameter. Now, there was a technical standardization group which shared lessons across the different contracts. Because of the varying depths and varying materials, that naturally led itself to different methods of construction. So in the clay, which is a competent material, you're able to have a face excavation and then spray concrete lining. Whereas when you're in the sands, you have to have a solid wall. So I believe there were diaphragm walls used in the east and the latter part of central, where they needed to control the groundwater and the potential movement of material within the shaft section.
Okay. And the last question we've got so far is, what work, if any, has been carried out at Beckton to prepare for the Tideway completion in 25?
Well, currently at Beckton, and there's a new inlet works being built, and there's some new aeration lanes being built and some new final tanks being built. That's ongoing at the moment.
Excellent, thanks for that, Stuart. There doesn't look to be any other questions so far. So, yeah, just with an eye on time, I'll probably look to leave it there. I just wanted to say thank you for both you, Kevin and Stuart, for such an informative presentation, for taking the time to share that with us. There are some links that have been shared throughout the presentation by Barbara, so that if there's any information required extra, then there is information there as well. I just wanted to, before we finish, just run through, just make you aware of some extra events that are happening within the very near future. Just to give you just a couple, this branch is running an event on the 13th of September on biodiversity net gain. That will be free to attend, and there'll be some information on that coming out shortly. There's some routes to membership events on the 18th of August. There is a on the 14th of October, there's a Yorkshire and Humber flooding conference that'll be hosted by the Tyne and Humber and ICE Yorkshire. And then between the 9th and 11th, there's an Urban Drainage Group virtual annual conference and expo for 21. I think that's everything for now. I haven't seen any other questions come through. So once again, I'd just like to thank you, Kevin and Stuart, for taking the time. I don't know the features of Zoom or whether you can send a virtual applause, but if you can, then please send those through now. But in anticipation of those, thank you very much for your time. And yep, we'll look to close the meeting now. So thank you everybody for attending.